So in this video we're looking at static electricity. First of all, what is static electricity? Electricity is always to do with electrons. That's the electric-electron thing. Electrons are negatively charged particles, and they usually orbiting a positively charged nucleus. So there's positive parts in the nucleus, and you have electrons orbiting around the outside. It's meant to be a circle with a negative in it, not to scale. Because there's four positive charges in here, you would expect there to be four negative charges around the outside as well for this atom. Now, static electricity is a build-up of electrons on one substance, so you have an excess of negative charges, or it could be that this thing on this side over here will have a charge imbalance, a lack or a deficiency of electrons, so that'll be positively charged overall. So that's how static electricity occurs, if you like, in the rough sense of it, is that those charges build up in one place. And the typical example, which I'm going to explain in another video, is the Van de Graaff generator, where it spins a thing and it causes a whole lot of static electricity on the top of a bulb kind of thing there, and then you bring another piece of metal close together which is attracted to the bottom, and then you get sort of zappy, sparky things going through the air. It's very cool, makes a loud crackling, crack, bam, bam, bam sort of noise, a little bit like mini lightning. So we're going to talk about lightning shortly, but static electricity, you also notice this when your clothes, you're taking off, say a woolen sweater. So you might have a woolen jersey, and underneath you've got a synthetic, one of those more plasticky type materials top, and when you pull the woolen part off, the synthetic part attracts it and it sort of sticks, and you get a crackling sound. And if you're in the dark, you can actually see sparks being produced in the synthetic undershirt that you're wearing when you pull it off. That's due to static electricity. So when they're touching, there's a build-up of charge on one and a deficiency of charge on the other, and the opposite charge, one becomes positively charged, one becomes negatively charged, and they're attracted. That's why it's hard to pull it off. You can do the same thing by rubbing a piece of paper, a plastic ruler. In fact, let's draw a little sketch of that. Get a ruler and you rub it on some wool. So plastic on wool, and then you get some little bits of paper, and you bring it close to those little bits of paper, and the bits of paper will jump up and may even stick to the ruler. That's also static electricity. So the idea, I guess, the whole static part of it, is that static means it's not moving, so you've built up charge in one place. Okay, compared to current electricity, current, when you connect a battery and say there's a resistor, and you'll have current actually flowing, so the electrons will move, the electrons actually move that way, and the positive charge goes the other way. That's in another video, the difference between electron flow and conventional current, but that's what current electricity is, a moving of charge. Static is not moving. Okay, so ultimately what causes it? We've talked about rubbing, so you can rub something to produce the charge. The Van de Graaff generator also rubs. It has a little belt inside of it that spins and turns around and deposits charge up here. How does rubbing actually do that? A lot of people think it's friction, and friction rips the electrons off. It's not friction at all, but it does rip the electrons off in that rubbing process. We'll come back down to the woolen example here. What it's actually doing is that the wool, the property of the material wool, it attracts, if it's wool, I think I'll double check this and I'll get back to you. Pausing. Okay, so it seems that the wool becomes negatively charged, so the wool attracts electrons more. If I've got this around the wrong way, at least the concept is right, that some substances attract more. So the synthetic stuff holds on to the electrons not as much, so it becomes a donor. So the woolen attracts, the synthetic becomes a donor because there's a difference between how strongly each of them hold on to the electrons. So the woolen can take a few extra electrons from the synthetic, and that leaves the woolen positively charged, the woolen negatively charged and the synthetic positively charged. And that's how you develop static electricity there. The Van de Graaff generator works in a very similar way. We're going to get into that, so I won't get into too much detail, but you have a substance down the bottom, another substance up the top, and you have a belt running. The substance down the bottom, I don't know which way around this goes, but the belt is made of a latex rubber. Down the bottom is made of a material that donates electrons to the belt, and then at this one, at the top, the material attracts the electrons, and that deposits the electrons on the top, so it might be negatively charged, not positively charged. Look at it there. And then when you bring this close together, it zaps it. Okay, so it's Van de Graaff generator as well. Lightning, very similar. Dust in the atmosphere, little dust particles. They're moving around through the air, and the dust compared to the air, if I get this around the right way, the dust attracts the electrons, and the air particles do not. They donate, more likely to donate. So if you get a whole lot of dust up high in the sky with the clouds, or water particles even rather than dust, you get a build-up of positive charge in the clouds, and then when that becomes high enough, all the electrons that are in the Earth, because the Earth is a great source of electrons as well as a great sink for electrons to go down to. In this case, they need them sourced, so the lightning will go zappy zappy up from the ground up, and the electrons will balance out the charge so it becomes neutral. In the case of whatever's in the air causing the clouds to become negatively charged, your excess of electrons on the top would come zappy zappy zap down, and then and sink into the Earth, and then you'd have neutral up the top again. So that's how static electricity, lightning and things like that work.